Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about molecular orbital theory. You know my friend, molecular orbital of a molecule is stated as the linear combination of atomic orbital. L for linear combination of atomic orbital and molecular orbital. Mathematically, it is represented as like that. Psi I is equal to C1 phi 1, C2 phi 2, C3 phi 3 and Cn phi n, which is equal to summation over I is equal to 1 to n Ci or phi I. This is mathematical representations. The energy of molecular orbital system is obtained by solving these equations. You know, this is very famous equations. Si is equal to E psi. Here H is Hamiltonian operator and E eigenvalue. The energy of a molecule arises from electron motion, internal vibration, rotational and translation. Electron motions, internal vibration, rotational and translation. The electron motion can be treated separately from nuclear motions. So we have the electron motions and nuclear motions. So Hamiltonian operator gives the energy of electrons for 2 electrons or 2 nuclei. 2 electrons and 2 nuclei. So for electrons, He is equal to H cross squared by 2m, summation over I is equal to 1 to 2 del I square minus summation over I is equal to 1 to 2 Z1 E square R 1I minus summation over I is equal to 1 to 2 Z2 E square R2I plus E square by R12. Here this portion is distance between electrons and nuclei, and this one distance between 2 electrons. So integral psi h psi d tau is equal to integral psi e psi d tau. Energy is equal to integral psi h psi d tau integral psi square d tau. Now friends, ab initio molecular orbitals. Solving the Schrodinger equation with approximation but not empirical parameter. Born Oppenheimer approximations. Separation of nuclei and electrons. You know the nuclei is different things and electron. Keeping nuclei fixed. The orbital approximation, the total wave function is considered as product of one electron's wave functions orbital. So psi is equal to psi 1, psi 2, psi 3 and psi m. According to Pauline's principle, the total wave function of an atom or molecule must be antisymmetric with respect to an exchange of the coordinates of any 2 electrons. So we have the semi-empirical methods like NDO, MNDO, AM1 and PM3. Density function theory, we have to calculate the electron density across the entire molecules, which correlate with the total energy of molecules, like E is equal to ET, EV, EJ and EXC, means electron kinetic energy term, potential energy term, Coulomb self-interaction term and exchange correlation term. So Huckel molecular orbital theory. 1. Only pi electrons are treated. Only pi electrons are treated. So sigma pi separations. And second, the basis set consists of n p orbitals, one on each of the n carbon atom of the pi system. So for ethene, psi pi is equal to C1 phi 1 C2 phi 2 energy integral C1 phi 1 plus C2 phi 2 operator C1 phi 1 plus C2 phi 2 d tau C1 phi 1 plus C2 phi 2 square d tau. So define psi phi 1 h phi 2 d tau integral phi 2 h phi 1 d tau. So this portion h11 Coulomb integral energy of an electron in its own orbit, h12 resonance integral interaction energy, and normalized integrals S11 and S12 overlap integral for adjacent data. So keep this parameter in your mind. Dou E and dou C1 is equal to 0. C1 H11 ESS1 plus C2 H12 ES12 is equal to 0. By variations principle, you can write it here. To solve C1, C2, you will get the H1 minus E S1 is equal to 0. So assume Sii is equal to 1, Sij is equal to 0, for I is not equal to j. Hii alpha, Hij beta if I and j are sigma bonded. So energy of an electron in an I orbital, same for all I. Interactions energy of an electron on the basis of orbital I and j, I and j orbital. So alpha minus E, beta, beta alpha minus E is equal to 0. If alpha minus E divided beta is x, then x 1 x is equal to 0. X square minus 1 is equal to 0. X is equal to plus minus 1. So E is equal to alpha plus beta plus minus beta. So E1 is equal to alpha plus beta, this pi. E2 is equal to half minus beta pi star. So you have the psi 1, psi 2, alpha plus beta, alpha minus beta. You have this psi 1, which is the pi and pi star. You know the pi star energy is greater than pi. So this is the bonding. And here you can see this is 0 electron density node molecular plane anti-bonding. For 3p orbitals of allyl system, again you have to set psi is equal to psi 1 phi 1, psi 2 phi 2, psi 3 phi 3. Then you have to write this from this x cube minus 2x is equal to 0. So E1 alpha plus 2 beta bonding E2 alpha and E3 alpha minus 2 beta anti-bonding. So psi 1, psi 2, psi 3, we have 3. So psi 1, psi 2, psi 3, alpha 1.414 beta. Quantitatively, you know, this is alpha, and alpha minus 1.414 beta. So this is the your bonding, anti-bonding, non-bonding. For 4p orbitals of the butadiene, again you have to solve this. So we have the 4, psi 1, psi 2, psi 3, psi 4. So here you can see 0.37251, 60252, and so on. So we have the psi 1, psi 2, psi 3, psi 4. For this is the bonding, anti-bonding. So 2 in bonding and 2 in anti-bonding. Same as for benzene. You can see here, you can solve like this. So we have the alpha here, E. So psi 1, psi 2, psi 3, psi 4, psi 5, psi 6. So this is orbital line. Now generalization. The number of nodes increase from 0 to n minus 1. The bonding and anti-bonding orbital are symmetrically placed above and below, means E is equal to alpha, or non-bonding level. Coefficient are symmetrical with respect to atomic orbital. So if you have the psi 1, psi 2, psi 3, psi 4, psi 5 and psi 6, in pentadienyl psi5 and hexatriene psi6. So you can see here psi1, psi2 1 node, psi3 2 node, psi4 and psi5. In case of this, you can see here. Now friend, correlation of physical properties with result of HMO calculations. You know the energy for ethylene means 2 electron in psi1 and E pi 2 alpha plus 2 beta. For allyl system, delocalized systems, you can see here psi1, psi2, psi3. So E is equal to alpha plus 2.828 beta. Here you can see in allyl radicals, this for allyl cation. Allyl radicals have 3 electrons, 3 alpha plus 2.828 beta. In allyl anion, you have the 4 electrons. So E is equal to 4 alpha plus 2.828 beta. And this is the arrangement. So compared to localized reference system, allyl cation, allyl radicals and allyl anion. So E is equal to 2 alpha plus 2 beta, E is equal to 3 alpha plus 2 beta, E is equal to 4 alpha plus 2 beta. So deglobalization energy is equal to 0.828 beta. Now in valence bond, allyl cations, you can see the arrangement, allyl radicals and allyl anion. So system is like that. The star stability is called resonance energy. For benzene, E is equal to alpha 6 alpha plus 8 beta. Resonance energy 36 kilocalorie. So beta is equal to 80 kilocalorie. Now friends, pi bond order. This you can see here Pij. Pij is equal to summation over occupied psi nci cj, where n is number of electrons in particular orbitals. This n. And CICJ is the coefficient of Ij bonded together for molecular orbitals. So for butadiene, 2 electrons in psi1 and 2 electrons in psi2. So this is the expressions you can see. And P12 and P23 expression is like that. So total you can see 1.895. All bonds are not same. You can see this one in 1.444. So bond order, sigma bond order plus pi bond order. Combinations of sigma bond order and pi bond. For excited state of butadiene, 2 electrons in psi1, 1 electron in psi2 and 1 electron in psi3. Then expression is like this. So total bond orders you can see here in excited state, first excited. Then you have to calculate the electron density. Psi is equal to psi1, phi1, psi2, phi2 and so on. To normalize, so C1 square, C2 square, C3 square and so on, which is equal to 1. If one electron occupies the orbital, Ci square is the fraction of the electron density on each carbon. So 2 Ci square for 2 electrons orbital. So formula becoming like that. For allyl systems, psi1, psi2, psi3, you can write it like that. For cation electron density, just calculate C1, 2 into half square half, charge density half, C2 0, C3 half. For radicals, 1, here 1, here 1, charge density 0, 0, 0. For anion, minus half 0 minus 2 electron density, and this is the C1, C2, C3. So charge density on each carbon, Qi is equal to 1 minus rho I. So correlations of bond order and bond length, you know, carbon-carbon, single bond 1.54 angstrom, double bond 1.34 angstrom, and triple 1.24 angstrom. So benzene bond order 1.627, 1.4 angstrom, experimental bond length 1.397 angstrom. This is the graphical presentation. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.